Is it too short, the duration? 2 days? You want me to shorten the times? Or given lesser exercises?
No, madam, okay, madam.
Okay, tapi ada juga yang tahan time and then want to make sure everybody can catch up. Okay. Right. So related to our Lewis structure. Okay, so we do a little bit of recap first and then we go into the Lewis structure. So from our last lesson, we have seen our Lewis dot symbol. Okay, and then that can figure out from your homework. Some of you mixed up between Lewis dot symbol and also Lewis structure. Okay, remember Lewis dot symbol, the very beginning that we use over here, this one is for a single element, single atom. For example, if I got carbon, carbon have 4 valence electron, then I have 4 valence electron located separately, the single electron. But it doesn't apply for your Lewis structure because Lewis structures, you need to follow the steps. If you remember step 1 until step 5. Okay, so that one is our Lewis dot symbol for a single atom. Okay, follow which element you want. Okay, from the periodic table. And then from our last lesson, also we look at the octet rule and also the exception octet rule. It have incomplete octet, we have expanded octet, we have odd electron octet. Okay, so for incomplete octet, remember there's only 3 elements. We have Be, beryllium, B, the boron, okay, and aluminium. They are from group 2 and also group 13. Okay, so Madam have already give out in your previous slide when we talk about the exception rules. And BE, B, and AL, the bubble, okay, you have to remember this few example. So Madam give you the example beryllium, hydrogen, BeH2, BeCl2, BeF2, whatever with Be. They are always they're always incomplete. Okay, they're always incomplete octet. So boron, whatever you match up with, either it's fluorine, hydrogen, chlorine, bromine, whatever with boron, okay, they are incomplete. But then for your aluminium, please be aware, aluminium match with what element? Okay, so if let's say you can see aluminium trichloride AlCl3, AlBr3, AlI3 over here, they are all covalent compound. They are all incomplete octet. Unless you see aluminium trifluoride. Okay, for group 13, only aluminium trifluoride is ionic compound. The rest of it are covalent. Okay, when Madam say about covalent, because Lewis structures over here, we are only looking at your covalent molecule or covalent compound. Okay. And also from your work, Madam give a few examples. Yeah, so I will take example from which class is it from? Yeah. Okay. Hazim, Madam ambil awak punya contoh ya.
Alright, no problem.
Okay. Right. So things about this one, it's not only Hazim, but some of about 4 to 5 students. You are doing
Madam,
the
I
same.
don't use the template.
Yeah, as I know, haven't opened yet. Okay. So for this one, right, Hazim, and also some of you, I can't remember who. Marcella. Okay, Marcella also you read the same thing. Um, don't confuse between our bond formations and the Lewis structures. The one that you are doing here, Hazim, is bond formation. So to record back over here, you see the 2-star Madam put over here, the ionic bond, covalent bond, dative bond. So you must show the Lewis dot symbol, arrow, and so on. This one is the bond formation. You show how the bond is formed, okay, between your Lewis dot symbol and then what is the product. So if we go back to the page that we do previously, Okay, chemical bonding. Okay, on this page, this is bond formation. Okay, all of this is chemical bonding, showing how the bonds is formed for ionic bond, how the bonds is formed in covalent bond, and how the bonds is formed in native covalent. But when we talk about the Lewis structure, you remember that Lewis structures is for covalent compound, whereby you need to follow this step. Step 1, step 2, 3, and 4, if you want to use the shortcut. Okay, and then step 5 if necessary. Okay, so the Lewis structure is based on your molecular formula. Calculate the total valence electron, and then we arrange how the electron should be located over there. So the total number of electron inside your Lewis structure should be the same as what you have calculated. Okay, so in your work, sometimes bukan sometimes ada juga yang tak tunjuk calculation. So madam nak juga semua orang kalau untuk soalan Lewis structure ataupun mengenai dengan Lewis structures, please show your calculation. Okay, calculation bukan yang paling minimum lah, madam nak nampak berapa total number of valence electron yang ada. Okay, so over here Hazim, make sure you remember masalah leaf and also Rauda Husna. Okay, so please make sure over
Oh,
here
madam.
we are
So
not,
the
yes, we are not showing the bond formation. For this template, if you can see, read the question properly. We want the Lewis structure instead. Okay, and then quite a number of you forgot to state the type of octet rule. Now, whether it is incomplete, it is expanded, or it is odd electron. For the normal, the usual octet, full 8 electron, and then you don't have to label. You just label for the exceptions only. Banyak juga yang tak jawab soalan yang kedua. Okay. So if you can see the example in exercise 2 here, all the structures are covalent molecule. Okay, none of them are ionic. So there's no such case as you have the square bracket and so on. So madam tunjuk satu contoh lagi ya. I take the
madam.
yes.
So can we just straight away give the answer? For example, we don't need to give A plus B equal to AB and such.
That one is bond formation. That is not Lewis structure, Hazim.
Oh, alright.
Lewis structure straight away to the structure. You are not
Aye.
showing how it is formed. Okay, for Rauda also the same. And then madam can detect Rauda answer and also Marcella answer is the same. I don't know who copies who, but make sure when you want to refer or you want awak nak rujuk jawapan kawan, make sure it is correct, then only you copy.
Madam.
Salin tak ada masalah, cuma salah pun awak copy macam mana? Ya, Hazim.
So when I want to do my correction, just straight away do the Lewis structure.
Yes. Calculation and
And
also
look out
Lewis.
for the BEBAL. Right?
Yeah, you check it later. Okay,
Alright.
for Raudha and also Marcella one, also you are showing the same thing. So remember, this question is about Lewis structure. And then when you have this kind of square bracket, that one is for ionic compound. When you want to show ionic bond, but obviously beryllium chloride, maybe you forgot lah. Okay, beryllium chloride that is covalent, it's not ionic, even though it's coming from group 2. Okay, remember BE, B, and AL, most of them are covalent. So dekat awak punya nota catat jugalah benda yang madam suruh awak catat. Okay. Okay, so when we're talking about the essential rule, madam have already give you the notes, yeah? But if you forgot to jot down this one, okay, the BE, B, and also AL, you can jot down now. Okay, beryllium, boron, aluminium, except aluminium trichloride is ionic. Then the rest of them are covalent and they are obeying incomplete octet. Okay. And then after that, we have also talked about stability of ion, the noble gas configuration, half-field orbitals or pseudo-noble gas. Again, we talk about bond length. We talk about formal charge. Some of you did calculate inside your exercises, which is which is good. You calculate the formal charge. Okay. And then for the resonance structures, we will repeat again for today. Okay, we will continue lah because last time we stopped halfway for the Lewis structures, more than one Lewis structures, and also the resonance haven't talked about yet. Okay, and then most plausible structures depends on the formal charge and the priority. So madam, let you look at the answer first, yeah, just in case you want to double check for it. So madam, show you the answer first, and then for you to check and do your correction. So if you have any question, you can ask it now for the Lewis structures. Because remember, Lewis structure is the basic that we want to use for the following subtopic. So make sure everybody can get a correct Lewis structure before you proceeding. Okay, and one more questions. Ada juga student yang tanya, Madam, kenapa saya tak boleh buat structure beryllium untuk jadikan dia octet? Okay, sebenarnya kalau awak kira ya, dekat sini, BeCl2, total you have 16 valence electron. So, it's actually you can do Be with 2 double bond, no problem, because if you calculated 2, 4, 6, 8, and then over here another 8 electron, total is still 16. So, maksudnya kedua-dua Lewis structure ni betul. Cuma untuk yang ini, dia octet. Ya, tetapi, okay, we want to choose the stable Lewis structure. You have to look at the formal charge. So Lewis structure yang betul kita tengok pada formal charge dia. So boleh tak awak tolong kirakan Lewis formal charge pada chlorine dan beryllium untuk structure octet beryllium. So to see why we keep the beryllium boron as the exception rules. So anyone for the Cl in Be with double bond?
0, 0.
The chlorine?
Also 0.
The chlorine 0. That one is for which one? The incomplete octet or the octet beryllium?
Incomplete.
Incomplete. Okay. So for incomplete over here, 7. Okay, 7 for the number of valence electron for chlorine. You minus 6 dot. Okay, and then you minus 1 line. 6 dot represents 6 lone pair electron. 1 line represents 1 bonding pair. So here we have 0. Beryllium valence electron 2 minus 2 bonding pair. You got 0. Okay, and then the chlorines are the same. Whereas if you look at the octet beryllium, okay, the one on the left-hand side, yeah, chlorine, we have 7 minus 4 minus 2, which give you positive 1. Okay, which is the same for both chlorine atom. How about beryllium? How about the middle beryllium with 2 double bond?
Negative 2.
Negative 2, because 2 valence electron, you need to minus 4 line, okay, or 4 bonding pair. So over here, we have a negative 2. So if you compare both of these structures, we will go for the beryllium, which obey the incomplete octet rule. So senang nak kata, awak hanya ingat kalau awak nampak saja Be, B dengan Al, mereka mesti incomplete. Okay. Kalau untuk yang expanded octet, dia boleh melalui octet dulu. Maksudnya dia capai 8 elektron dulu. Lepas tu dia nak expand boleh. Dia tak nak expand pun boleh. Untuk expanded octet, there's 2 options. Sebab nak penuhkan 8, boleh. Nak lebih 8, dia pun boleh. So for the expanded octet, they have 2 options. So either one will be correct. But for the Be, B, and Al, they always incomplete. Okay. So, Madam bagi check untuk yang bottom part. E until J. So, for your GSO2, you have two answers. Either you have sulfur with two double bond, okay, or one double bond, one single bond. So, the one double bond, one single bond, this one is octet. Okay, and then if you got two double bond with one lone pair, this one will be expanded. Okay, since sulfur is come from your period tree, it has empty 3D orbitals. Therefore, it can expand. Okay, lepas tu hari tu Meda ada bagi tahu untuk H dia ada satu pembetulan missing a positive charge ya. Okay, dekat sini ada apa soalan lagi yang boleh Madam tolong untuk explain? Ada sesiapa nak tanya
Madam,
soalan ke?
for question G, why is there two answers for the Lewis structure?
For G.
Yes, madam.
Because octet can be applied for all except for the incomplete. So sulfur can expand. Okay, sulfur can expand because there is empty 3D orbitals. Therefore, you can achieve the octet first, and then after that, you can do expansion for the center sulfur atom. Okay, so there is two answers for G. So if you want to refer to the most stable one, then we go for the expanded octet.
Teacher.
Yeah.
Apa?
Kalau
Ya,
yang
kenapa?
kalau kan kita tambah bonding kan dekat S tu kan, jadi ada 4 bond kan. Kita tak payah buang dia punya lone pair tu Maksudnya kan kita dah gantikan, tak payah.
Tak. Irfan cuba kirakan dia punya total electron. Sebab total electron yang pada awak punya Lewis structure, dia mesti kena sama dengan apa yang awak kira dekat sini. So, kalau awak kira kan, dekat atas sini ada 18, dekat bawah sini pun 18 juga.
Okay, faham.
Cuma kita pinjam salah satu lone pair daripada oksigen kedua ni untuk buatkan double bond. So, kalau awak kirakan dia punya formal charge, sulfur yang kedua ini, dia akan jadi kosong. Sebenarnya dia lagi stable. Tapi sebab untuk expanded octet, dia boleh octet, dia pun boleh expanded sebab dia ada empty subshell, empty orbital. Tapi untuk incomplete, kita akan ingat untuk letak incomplete sahaja. Ada juga soalan yang minta awak untuk comparekan beryllium with two double bond and then beryllium with the incomplete octet. So itu akan jadi tadi lah macam mana Madam comparekan. Okay?
Okay, faham.
Okay, so untuk yang lain buat pengiraan bukan pengiraan. Those who forgot the calculation, please include your calculations.
Madam?
Yeah?
Madam, so for the expanded octet, we can say there is a dative covalent bond formed in the compound, right?
Dative covalent, why?
Because there is an empty orbitals and the lone pair will...
No. No. In Lewis structures, we are not talking about the dative. Dative bond is like two separate things. Okay, two separate things. For example, last time we used the NH3 with the H+. So there's two separate things. But this Lewis structures, you got only one structure. So there's not two different species. But dative bond required two separate species.
Oh, okay. Thank you, Madam.
All right. This is just one species. Whatever you look on here, everything is just one molecule, one species only. Madam guna perkataan species, dia merangkumi molekul, dia merangkumi ion ataupun compound yang besar. So Madam guna perkataan species. Okay, ada soalan lagi? Okay, if no question, then we proceed to our plausible structures. Yeah, so to recall back, most plausible structures, we use the priority to compare. Okay, whether they have zero formal charge, the smallest formal charge overall, or the negative formal charge on the more electronegative atom. Okay, so question number 1 is about carbon dioxide. So last time we have already talked about it. And then question number 2 is POCl3. So phosphorus, how many valence electron? Kita buat sama-sama ya. 5. Okay, how about oxygen?
6.
And the chlorine? 7 times with 3, we have 21.
21.
So altogether, how many? Agree?
Yes.
Who will sitting in the middle? So this one is your step 1. Always do your calculation. This one is just for you to make sure you're using all these 32 electron to build out your structure. Okay, so who is sitting in the middle? P, O, or Cl? Who is the least electronegative? No idea?
P.
Phosphorus.
Phosphorus sitting in the middle, yeah? Okay, so because phosphorus is the least electronegative, you can refer back to your periodic table to check for the electronegativity. Okay, and then surrounding it, it has 4 more atoms. We have oxygen, we have another 3 chlorine. Okay, so now this is step 1. Step 2. Now, Madam want to show you the shortcut in the video that Madam sent the other day, yeah? To combine between step 3 and step 4. Sebab Madam rasa mungkin ada orang yang lebih prefer kepada shortcut. Kalau nak full step, awak boleh refer balik kepada nota. Okay, so shortcut over here, after you creating your skeletal structure, awak letak dulu octet electron, penuhkan electron untuk surrounding atom. So over here, oxygens, I surround with another 3 more lone pair, chlorine as well, and then complete the rest of it. Okay, yang ini shortcut kita combinekan step 3 dengan 4. So now, the overall electron inside this structure, how many? There's 8 each, right? For chlorine, 8. Oxygen also 8, and then there is 4, so 8 times 4, we got 32. So we have already completely using this 32 electron. So that means this is your first structure. Done already. Okay. Have you tried drawing the skeletal structure for this one? Dah cuba ya? Yes.
Dah.
Dah. Okay. Macam mana nak dapatkan structure yang seterusnya? Dia sudah octet, sudah penuh, madam. Macam mana kita nak buat structure yang lain? Kita check phosphorus dari mana. Phosphorus is from period. Period, which period? Period 3. So maksudnya dia ada empty 3D orbital. Maksudnya dia boleh octet, dia pun boleh expand. Okay, so when it can expand, we can do expansion using the lone pair from your surrounding atom, which is your step 5. Sebab kita nak keluarkan soalan minta all possible Lewis structure. That means there is more than one structure. Okay, so now in this case, Madam want to inform that for group 17 element, fluorine, chlorine, bromine, iodine, it can only form single bond all the time. Okay, fluorine, chlorine, bromine, iodine only form single bond. Okay, so there's only one choice that you can do double bond, which is using the lone pair on your oxygen. Okay, so kita ambil salah satu lone pair daripada oksigen awak untuk buatkan Lewis structure yang kedua. Okay, so the second structure is also the same. We have chlorine, 3 chlorine, and then every chlorine is octet. And then we're borrowing one of the lone pair from oxygens to make double bond. So now oxygen left with 2 lone pair. So this is your second structure. It's still the same. The number of valence electron surrounding this structure 2 still 32. Okay, masih sama lagi lah. So, maksudnya kedua-dua structure ni adalah betul. Okay, dengan valence electron yang betul, yang cukup. Okay, so now we only have 2 of this structure because chlorine can only make single bond. So there is no double bond on chlorine. Then we have to calculate for your formal charge. So we try this one together. What is the value for oxygen? Anyone? What is the value for oxygen for our first structure?
-2.
-2.
-1.
-1. Okay, oxygen 6 valence electron. Dekat oxygen ada 6 dot. So 6 tolak 6. Ada satu line tolak lagi satu. You can do your calculation, yeah? If you want to. So I put structure number 1 oxygen. So this calculation you don't have to show because it's just a simple calculation. Cuma awak kena tahu macam mana nak kira lah. Okay, so untuk structure yang pertama, oxygen dia 6 tolak 6 sebab lone pair electron ada 6 dot. Okay, satu line tolak satu. So dekat sini adalah -1. Okay. Whereas for chlorine, 7 minus 7 minus 1 give you also -7 pula, -6 minus 1. So the chlorine over here give a value of 0. All chlorine are the same. How about phosphorus? For the first structure.
+1.
+1, +1. Okay, so we got our formal charge for the first structure already. Then come into the second structures. Chlorines are still the same. Okay, 0 formal charge. But how about the oxygens on the second structure?
0.
0 because 6 minus 4 minus 2. Ada 4 dot, ada 2 line. Okay, so dia adalah kosong. How about phosphorus?
0.
Also 0. 5 minus 5. Oh, ada 5 line dekat situ. Maka dia punya formal charge adalah kosong. Okay, so the most plausible structure is which one?
The second structure.
Second structure. Okay, the reason you follow the priority, and in this case, we have all 0 formal charge for all atoms. Okay, so the reason is the same as our question number 1. 0 formal charge on all atoms. Kalau awak rasa awak nak kira dekat tepi untuk formal charge, boleh awak boleh buat draft dekat sini. Dekat tepi. Tapi formal charge calculation, if the question doesn't request, you don't have to show.
Madam.
Yeah.
So we need to show the calculations for the valence electron, right?
For Lewis structure, yes.
The PO3Cl, we need to show it, right?
Yes. This calculation,
And
yes.
also-
This calculation is for Lewis structure is a must. Formal charge, no need.
Alright, noted.
Okay, because the calculation for Lewis structure sometimes is got charge, then you have to show you add the charge or you subtract the charge. So it's important for Lewis structure. Okay. So our question number 3, possible Lewis structure for SCN. So first thing first, calculation. Sulfur,
6.
carbon,
Oh.
nitrogen,
5.
5 ya. Madam nampak juga ada yang tulis 7. Make sure nitrogen proton number yes 7, but the valence electron is 5. Remember, nitrogen, phosphorus from group 15. Okay, and then there's a negative charge. Don't forget, when you have negative charge, that means you have extra electron. So include also 1 electron. So calculate the total.
16.
Okay, so who is sitting in the middle in your skeletal structure? Sulfur, carbon, or nitrogen?
Carbon.
Carbon. Okay, carbon. Carbon adalah the least electronegative between sulfur and nitrogen. So we put carbon in the middle. Okay, so sama jugalah sekarang sudah ada skeletal structure. So kita penuhkan surrounding dulu sebelum kita kira lah. Combining step 3, step 4. Okay, so now if I complete my surrounding atoms with octet electron, so now you can see in this structure, I have already used up the 16 electron. Okay, over the left-hand side, carbon, sulfur here, we got 8. And then carbon, nitrogen here, we also got 8 electron. So finish use up. You don't have extra electron. Dah tak ada dah. So bila awak tak ada lagi elektron, awak tak boleh main letak elektron saja. Kena base kepada elektron yang sedia ada untuk build out Lewis structure ini. Okay. So if you don't have extra electron, then we have to use step 5. You have to proceed to step 5. Because in this case, carbon is not yet octet. Kalau awak rujuk kepada sini, carbon tengah ni belum octet lagi. Dan dalam incomplete octet rule tak ada pun carbon. Hanya BE, B dengan AL, tak ada carbon. So maksudnya carbon dia mesti octet. Okay, carbon mesti octet. So in this case, we have to borrow your surrounding lone pair. Okay, so let's say I borrow from sulfur first to make a double bond. Still the same, 16 valence electron, but carbon is not yet octet. Then I borrow another one. I borrow another sulfur, okay, to make a triple bond. So now this structure, sulfur, carbon, nitrogens, all these 3 atoms achieving octet. Okay, achieving octet, and then it's fulfilling the 16 electron. Then that's okay. This is your first structure, the correct structure. And don't forget, when there is a sign, you need to put a big bracket and then put a sign on the outside of your bracket. So this, you put it as structure number 1. Okay, then we proceed lah. You want to do the second structure. Okay, second structure slightly easier. You can base on the first structure, just transferring between your bonding pair and the lone pair. So maksudnya macam hari tu yang Madam tunjuk lah, Madam guna warna lain dia bukan Lewis structure tau. Madam guna warna lain untuk tunjuk macam mana kita nak shiftkan dia punya bond untuk jadikan Lewis structure yang lain. Okay. So second structures over here we have sulfur, carbon, nitrogen. Okay. And then the sulfur now from triple bond become double bond. So you got 2 more lone pair. From single lone pair just now, 1 lone pair, now sulfur have 2 lone pair. Then the carbon over here, one of the lone pair from nitrogens, we move into here to make a double bond. So now nitrogen's left with 2 lone pair. Okay, so kita pindah lagi untuk jadikan okay, untuk jadikan dia structure yang ketiga. So this one is your second structure. Are you still following?
Yes, madam.
Yes.
Okay. So how about your third structure? What is it? How will it look like? Structure yang ketiga macam mana? Carbon?
Triple bond.
Yes, triple bond, and now the nitrogen's left with 1 lone pair only. So this is your third structure. Okay, so we have triple bond, single bond, and then double bond, and then single bond, triple bond between 3 of these atoms. Is everyone okay?
Yes, madam.
All right. So now calculate for the formal charge for 3 of this structure. The first one, sulfur. When you're using a different color, you just label the formal charge over here. Sulfur berapa?
+1.
Positive 1. 6 minus 2 minus 3. Carbon?
0.
Nitrogen? 5 minus 6 minus 1. 5 minus 7. We got negative 2. Okay. Boleh ke semua?
Boleh.
Like second structures, sulfur now becoming 0 because valence electron 6 minus 4 dot minus 2 line give you 0. Carbon still 0. Nitrogen 5 minus 4 minus 2 give you a value of, what's the value given?
-1.
Negative 1. How about structure number 3 for sulfur?
-1.
Okay, for nitrogen?
0.
0. Okay, so from these 3 structures, obviously you can see structure number 1 is out because you have a negative 2, which is not the lowest that we want. So you cancel out last structure number 1. Okay, now we want to determine which one is the most plausible structure, most preferred structure, most stable structure. Then it will be between structure 2 and 3 because they have similar set. So 3 of the atom, only one having -1 formal charge. But now you have to look at who is holding the negative charge because both of these structures having lower formal charge. Then we have to determine the more electronegative atom should be the one that holding the negative formal charge. So which one is preferred, 2 or 3? Nitrogen or sulfur, which one is more electronegative?
Nitrogen.
Nitrogen. Sebab awak ingat FON. Fluorine pertama, oksigen kedua, nitrogen adalah tempat ketiga. So kalau awak sudah tak nampak tempat 1, 2, 3, sulfur dengan nitrogen, obviously nitrogen is more electronegative. Okay, so the preferred structure will be structure number 2 because it has the lowest formal charge and the negative charge is placed on the more electronegative nitrogen atom. You have to indicate which atom. Because sometimes you need to compare between nitrogen and oxygen, then you have to choose which one is more electronegative. So untuk yang ini penting kena highlight kan atom mana satu. Okay, so this is question number 3. Any question you would like to ask?
No meeting.
So we need to highlight the most electronegative element first. Am I right?
Yes, you need to write out.
All right.
Okay, so 3 of these questions, if you look at the pattern of the questions asking, they ask you to draw all the possible Lewis structure. Okay, so we can conclude these different Lewis structures as the resonance. So this is another new name. Okay, resonance structure. Kena faham, kena tahulah definition untuk resonance ialah apa. So resonance refer to when you have 2 or more Lewis structures for a single molecule or for the same molecular formula that cannot represent accurately by only one Lewis structure. Okay, I will use a fan to represent your resonance. Kalau awak ingat kipas, atas sini ada kipas kan. Dia biasanya ada 3 pedal. Okay, if you remember about your fan, got 3 pedal over here. Okay, but if you didn't switch on your fan, you can see there's 3 pedal. But when you turn it on, you can only see a big circle. Keeps rotating, right? this is resonance. Kalau awak nampak separately, dia adalah Lewis structure yang berasingan. Tapi sebenarnya resonance ini dengan formula yang sama, mereka sebenarnya represent satu molekul sahaja. Cuma arrangement elektron berbeza. Okay, so two or more Lewis structure represent one single molecule. So kena faham untuk resonance structure. So over the example here we use O3, the ozone. You can see three of the atoms are similar. So you have to try draw out the Lewis structure using our practice step 1, step 2, step 3, step 4, step 5. So dekat sini sudah bagi dah awak Lewis structure dia. So dekat sini awak akan nampak oxygen. It can have a double bond on the left or the double bond on the right. And we are using this arrow to represent that both structures are resonance structure. So biasanya kalau ada resonance structures, awak akan guna arrow ini. So kalau kita patah balik kepada plausible structure yang tadi, dekat sini. Okay, so untuk carbon dioxide for example. Madam pun boleh letak sebab ketiga structure ini adalah resonance. So saya bolehlah letak saya punya resonance arrow. Okay, antara ketiga structure ini. Okay. And then you have to make sure you understand lah both of these actually they link to the same questions. Which one is the most plausible structure? So masih guna lagi priority reason dekat sini. So kita tengok dekat structure ni. O3 sebab dia tak ada perbezaan, the structure have the same typing error, have the same relative placement of atom but different locations of bonding. Okay, same relative placement of atom, different locations only. So using the resonance arrow to represent the relationship between both of this structure. Okay. Then another example using resonance structures. So you look at the questions, draw all the resonance structure. Tukar sikit soalan dia. Tadi dia suruh awak tulis all possible Lewis structure. Now they ask you the resonance structure. Okay. So bila awak nampak perkataan resonance, mesti kena ada arrow. Kalau dia minta Lewis structure sahaja, tak letak. So dia punya perbezaan dekat sini. Minta resonance, baca soalan dulu. Dia minta resonance, mesti kena ada arrow lah dekat situ. Okay. So now this question is asking for NCO. So carbon is the least electronegative, so it will be in the center. Okay, so similar like SCN just now. To draw your NCO, again, you need to calculate for the total valence electron. So this one, I leave it to you because the structure is already given here. Structure 1, structure 2, structure 3. Okay. So in this case, similar like SCN negative, structure 3 is the most plausible structures. Okay, because it has the lowest formal charge and the negative formal charge is located at the more electronegative oxygen atom. So if you're comparing between our structure 2 and 3, the negative charge on structure 2 is located on nitrogen, but the negative charge for structure 3 located on oxygen. So kita compare lah antara structure kedua dengan ketiga sahaja. Sebab structure pertama bila awak nampak dua ni automatic out. Is that okay? Ada soalan ke untuk soalan pertama ni? Sebab jawapan sudah bagi. Kita hanya compare untuk electronegativity untuk oksigen dengan nitrogen. Okay. Ada soalan ke untuk soalan pertama ni? NCO minus.
Madam,
Yes.
I want to ask about the O3.
Okay.
The O3, if the question were to ask us which is the most plausible structure, then what will be the answer?
Have you tried to calculate the formal charge?
But it seems the same for both sides.
Yes. So if it's the same, then the question will not ask about the plausible structure because it's the same value.
Oh, okay, I see. Okay, thank you, madam.
Okay. They are the same structures, but just different locations of the double bond. Because all three atoms are the same. So the formal charge will still be the same, but the question normally won't ask. Okay, we try one more question before we proceed to the next part, yeah? N2O. Ada dua nitrogen, ada satu oxygen. Has three resonance structure. Draw all the three resonance structures and determine the most plausible structure from their formal charges. Okay, so in this case, nitrogen, we have 2. Nitrogen, 5 valence electron. Over here, we have 10, we have 6, we have 16. Okay, now the question is, N2O, step number 2. Skeletal structures, who will be in the center? Nitrogen ke oxygen, mana satu least electronegative?
Oxygen.
Nitrogen.
Nitrogen.
Kita ada FON, tempat pertama, tempat kedua, tempat ketiga. So nitrogen is the least electronegative. So soalan ini dia nak trick awak Walaupun satu oksigen saja, tapi oksigen bukan center dia. Okay. So we build out the skeletal structure first with the least electronegative atom stand in the middle. So structure dia adalah NNO. Okay. Lepas tu guna step ketiga, step keempat, kita penuhkan surrounding atom with the octet electrons. And now we have finished using that 16 electron. Madam rasa ada yang tak faham macam mana nak kira, Madam tunjuk sekali dekat sini Cara nak kira dia punya elektron. Sekarang Madam combine step 3 dengan 4. So you calculate it like this. 2, 4, 6, 8, 10, 12, 14, 16. So all together is the same as the one that you calculated. Is that okay? Sebab satu line ada 2 electrons lah. Lepas lone pair, kita kira 1 dot, 1 dot. Okay, so now we want to make sure. Madam salin balik Okay, nitrogen, the center nitrogen is not yet octet. Then we have to proceed to step 5. Borrow the surrounding atoms lone pair to build multiple bond. So similar like just now, I borrow one of the pair, I build double bond. 8, center nitrogen is not yet octet. Then I borrow another one to build out. So this is my first resonance structure. Then because the questions have already mentioned resonance, put down your arrow, double-headed arrow, and then build your second structure by moving around the lone pair and the bonding pair. So using a different color, going inside, going outside. Because remember, nitrogen, oxygens, they can only obey Octet Rule. Tak ada incomplete, tak ada expanded. So semua kena 8 elektron juga. Okay. So second structures, 2 lone pair on the first nitrogen, then it becomes double bond, nitrogen, double bond, oxygen. So now oxygen's left with 2 lone pair. This is your second structure. Total number of valence electrons still the same. Then we proceed again, moving in, moving out to create a single bond nitrogen, a triple bond oxygen. So this is the third structure. Okay, you always start with one correct Lewis structure before you proceeding to the second and the third. So, ada masalah ke untuk soalan macam ini? Ada soalan? Tak ada soalan? No. Okay. Tell me which one. 1, 2, 3. Which one is the most plausible? Ada tak plausible structure?
3.
Dah calculate
One.
from the charge? 1, 3, 1, 3. Kita tengok. Kedua dekat sini 5 tolak 6, negatif 1. Dekat tengah memang positif 1 lah sebab dia 4 bonding saja. Okay, and then oxygen we have 0. The third one, nitrogen, 5 minus 7 give you negative 2. Uh-oh. Dan nampak negatif 2 automatic out lah. Dekat sini positif 1 pula. Positif 1 tak? 6. Ni salah ya. Center nitrogen is positive 1 ya. Okay. So, structure yang ketiga automatic out sebab awak nampak 2. Tak kisahlah dia negatif 2 ke positif 2. Sebab dia bukan lowest dah. So, we choose between 1 and 2. Which one is most plausible?
1.
First
The first one.
Why 1? Why 1?
More apa ni?
Apa ni?
Electronegative.
Yeah, negative charge fall on the more electronegative oxygen atom. Sebab kita bandingkan oksigen lagi elektronegatif daripada nitrogen. Okay, so jot down your answer.
Madam, dekat sini yang structure yang ada satu bond je tu tak kira sekali
Sorry, structure dengan?
Yang single bond tu, yang ke atas sekali.
Oh, yang atas ni?
Ya.
Yang ini bukan sebab nitrogen dia below octet. So, kita tak ambil dia sebagai Lewis structure. Lewis structure bila awak sudah cukup elektron, cukup octet. Ataupun kalau dia bukan octet, dia mesti incomplete ataupun expanded. So, dia mesti kena structure yang betul. Ini structure tak complete lagi. So, kita tak kira. Okay?
Baik, madam.
So, Madam cakap sangat penting untuk Lewis structure untuk awak practice lah sampai betul. Tak kisahlah sekarang tak faham ke practice. Keep on practice. Using the same structure also doesn't matter. You have to. Okay, have to get the idea how to draw Lewis structure. Okay, so untuk exercise dekat sini soalan 1 hingga 5. Soalan pertama Lewis structure. Soalan kedua sampai ke 5 dia adalah contoh exam style questions. Okay, so Madam ambil contoh dekat soalan yang keempat. Okay, so if you look at question number 4, Madam discuss one question with you. Okay, so referring to iodate ion. Sebab Madam rasa 2, 3 dengan 5 senang lah. Okay, so referring to iodate ion, draw all possible Lewis structure. Okay, choose the most possible Lewis structures. So this one you need to use the formal charge to explain. And then why IO3 negative disobey octet rule. So bila awak nampak disobey octet rule, sama ada dia adalah incomplete, expanded or odd electron. Then for B, using Lewis structure, show and label 3 types of chemical bonding. Exist in ionic compound ammonium chloride. NH4Cl. So dekat sini show the chemical bonding. So just now in the earlier of the Google Meet, Madam say Lewis structures refer to the covalent compound, isn't it? So that means based on the formula, you following the step, you creating the structure. But there is still cases where the questions asking Lewis structure for ionic compound. So nanti awak akan tanya, Madam kan cakap Lewis structure untuk kira-kira valence electron adalah untuk covalent. So macam mana kita nak buat untuk ionic? So ionic macam biasa, Lewis structure dia tak ada option lain. So contoh kalau MgCl tu yang hari tu kita buat, inilah adalah Lewis structure untuk ionic compound. So maksudnya dia tak boleh tunjuk bond, dia mesti tunjuk charge sebab dia adalah ionic. So this is the structure or the product for our ionic compound, or the Lewis structure for ionic compound. Yang lain covalent compound ikut step. So for the part A, I think I want you to do it first. And then for part B, Madam will show you the answer. So if you can see NO4Cl, this is slightly difficult, yeah? NO4Cl is slightly difficult. You can separate look like this. NH4, it has a positive charge, Cl minus. So between both of these is your ionic bond. Okay, so the questions say there is 3 types of chemical bonding. That means there is covalent as well, there is dative bond as well. So you have to recognize inside your NH4 positive, there is dative bond, there is covalent bond. So you have to show it. Okay. Show the products only. If you want to refer to the starting until the end, also no problem. So Madam show you the final products only. Yeah. So this is NH3. In order to form NH4 plus, you know that we're donating the lone pair from nitrogen into the empty orbitals inside H plus. Because in order to form NH4 positive, you have NH3 plus H plus into NH4 positive. Okay, so I hope you still remember about this structure. Even though you don't want to show this arrow, doesn't matter, you show this bonding. But you have to recognize NH3, dalam NH3 adalah kita punya covalent bond. Sorry, I Madam draw it again. So and inside NH3, yang original nitrogen ini, bonding ini adalah covalent bond. Okay? Lepas tu bila dia donate electron kepada H positive, it become like this. It becomes our structure this way. So over here we need to label. This is the covalent bond. This is the dative bond. Walaupun tak tunjuk arrow pun boleh. Nak tunjuk arrow pun boleh. Tapi pastikan arrow awak adalah betul. Okay. And then we combine with Cl negative. Okay. And this one, in between the bonding here, between your NH4 positive and also Cl negative, this will be your ionic bond. So you have 3 types of bonding inside the structure itself. NH4Cl. Inside NH4 plus, covalent and dative covalent. Between NH4 positive and Cl negative, there's ionic bond. And this apply the same as in question number 5, when you got NH4 N3. So that N3 refer to N3 negative. Okay, so please try the question number 1 again, practice Lewis structure, and then 2 until 5, Madam will record the answer and for you to check. Next question just now, Madam. 1 to 5. Tapi tak perlu hantar dekat GC. Cuma Madam nak awak cuba untuk buat, nanti check balik jawapan. Because I have another question for you to submit in Google Classroom. Okay, so ini untuk praktis sendiri. Jawapan Madam akan bagi kemudian ya. Okay, yang ini dah siap salin ke untuk part B? 4B.
Ya, medium.
Dah siap salin?
Yeah.
Okay, then if you have done, we want to proceed to 4.2. Molecular shape and also polarity. But this hour we will try to do molecular shape only. Polarity will be on Thursday. So proceeding into your 4.2, explain valence shell electron pair repulsion theory, or in short, we call it VSEPR. Or you can heard some of the lecturers say Vesper Theory. I don't know where it's come from lah, but VSEPR sometimes called Vesper in short. Okay, or in full, valence shell electron pair repulsion theory. Okay, we want to draw the basic molecular shape. There is 5 altogether. And then we want to predict and explain what is the shape of that molecule and the bond angle between them. Okay, and then for D and E will be at next hour on the coming lesson. Okay, so Madam go through with you the notes over here, and then we will do a little bit of drawing. Okay, so valence shell electron pair repulsion theory say that each group of valence electron, including your bonding pair, lone pair, or every electron pair, okay, around the center atom located as far as possible to minimize repulsion. That's why you said Vesper, you got the electron pair repulsion theory. Okay, so memorize understand the theory to locate each electron pair as fast as possible to reduce repulsion. So this Vesper theory is used to predict your molecular shape. Molecular shape can also means molecular geometry. Ada masa soalan minta molecular shape, ada masa dia minta molecular geometry. Benda yang sama ya, cuma nama berbeza. Okay, and Vesper theory also used to obtain the bond angle. Bila awak sudah dapat shape, mesti akan ada bond angle. Okay, bond angle between the electron pair. I'll show you where we can obtain that one. Okay, so point number 3, lone pair electrons are closer to nucleus. Okay, therefore they exert a stronger repulsion to one another. So lone pair sebenarnya dia macam satu electron cloud. Okay, the space is very big. So that means the repulsions within the lone pair is very huge. Instead of you have a bonding pair. So we can arrange the electron pair this way. So Madam harap awak faham untuk lone pair dengan bonding pair kita maksudkan apa. So Madam nak awak tengok dekat diagram dekat sini. Kita ada dua perkataan lone pair ataupun bonding pair. Okay, lone pair, if you look at your first structures here, lone pair adalah yang this one. Yang ada bulatan dekat sini. Biasanya kita lukis H2O macam ni saja kan. Sebenarnya lone pair ini dia macam satu cloud. Dia besar sikit. So this one is your lone pair. Ni ataupun ni adalah lone pair. Cuma lukisan dia berbeza. Biasanya awak lukis macam ni dah boleh. Tak perlu lukis macam ada satu droplet macam ni. Tak perlu lukis ini saja. Okay, lukis yang biasa, lone pair biasa saja. Okay. And manakala awak punya bonding pair adalah antara hydrogen dengan oksigen. Benda ni, Madam highlightkan. Ini adalah kita punya bonding pair. This is the bonding pair. This is the bonding pair. This is the bonding pair. So you have to make sure lone pair, bonding pair refer to which one. So in your Vesper theory, the order of repulsion between lone pair, okay, so repulsion between both of this lone pair is stronger. Okay, compared to lone pair bonding pair. Kalau tengok pada kedua ni lone pair bonding pair, maksudnya antara lone pair dengan bonding pair punya repulsion. Okay, and then it will be greater than the repulsion between bonding pair and bonding pair. So in between bonding pair, then maksudnya antara dua bond dekat sini. Okay, so if you look at the CH4, dia hanya ada repulsion bonding pair saja sebab dekat CH4 sini tak ada lone pair langsung. So only bonding pair repulsion. If you look at NH3, there's two type of repulsion between lone pair, bonding pair, and also between bonding pair. Whereas you look at the structures for our H2O, dia ada 3 jenis semua. Repulsion between lone pair, repulsion between lone pair, bonding pair, and repulsion between bonding pair. Nah, so mesti kena tahulah lone pair refer kepada apa, bonding pair refer kepada apa. Or you can also refer to this one. Vesper Theory say lone pair repulsions greater than lone pair, bonding pair, greater than bonding pair. Hilang satu pair dekat sini. Okay. Mesti kita akan pakai Vesper Theory untuk predict lah kita punya molecular shape. Dan ini adalah dia punya explanation. The one that Madam tick over here is the explanation that we are going to use later. So you need to remember about this comparison. So now, any questions about Vesper Theory? Bolehkah faham repulsion antara kumpulan-kumpulan dekat sini?
Boleh.
Boleh.
Boleh, madam.
Kan ya. Okay. So the next thing we want to see is determine electron group. The following counts at 1 electron groups around the center atom. Okay, 1 electron groups, yeah. So when we say about bonding pair, it includes single bond as 1 pair. Double bond, even though 2 line, is also 1 pair. Triple bond is also 1 pair. Okay, so over here, if you look at the first one, CH4, we have 1, 2, 3, 4, 4 bonding pair. Okay, that means 4 electron groups. 1 pair, 1 group. 4 pair, 4 groups. If you look at CO2, okay, CO2, focus on our central atom. In this case, central atom is carbon. Double bond considered as 1 pair, 1 bonding pair, and then another one considered as another bonding pair. So for carbon dioxide, there is 2 bonding pair, therefore 2 electron groups. So ingat double bond, triple bond pun kita consider as 1 group. Okay. And then second one is the lone pair. One lone pair considered as 1 group. So if you look at H2O, we have 1 group, 2 group for the bonding pair. We have 1 lone pair, 2 lone pair. So altogether, 2 bonding pair, 2 lone pair, and you have 4 electron groups. Okay, so bonding pair single bond 2, and then lone pair kita ada 2 pair. So jadi total kan kita ada 4 group. So again, we look at Ni3 at the bottom here. Kalau fokus dekat nitrogen, kita ada 1 bonding pair, 2, 3. So 3 bonding pair. And then 1 lone pair on nitrogen. So altogether, we have 4 electron groups. Is everyone okay in calculating electron groups?
Okay.
Ini nak kira kumpulan saja kumpulan berapa? Ada 2 kumpulan ke, 3 kumpulan ke, maksimum kita akan pergi kepada 6. Okay. Lepas tu lone electron. Bila kena asingkan lone pair maksudnya satu pasangan, 2 elektron dalam satu pasangan. Tapi bila awak akan ada lone electron maksudnya 1 biji elektron saja. Single electron. That one also we consider as 1 group. Okay, so if you look at NO, nitrogen monoxide, here don't have the central atom. Sebab 2 atom saja kita tak dapat nak bezakan siapa center. So kita akan ambil kira kedua-dua atom. So if you look at nitrogen first, we have 1 group. Okay, we have 1 lone pair. Okay, and then we have 1 lone electron. So kalau fokus pada nitrogen ya, 1 bonding pair, 1 lone pair, 1 lone electron. Jadi dia adalah 3 electron group. Okay, proceeding to oxygen. Okay, oxygen has one double bond, one bonding pair. And then you have two lone pair. So one bonding pair, two lone pair. So untuk oxygen pun sama jugalah, 3 electron group. Okay, so now madam want to try if you know already how to calculate the electron group. So let's see the first structure over here. Can you tell me how many groups does the hydrogens have? The first hydrogen.
1.
1 electron groups. Okay, how about the second hydrogen?
Also 1.
1.
Okay, second hydrogen also 1 group. How about the first oxygen? Madam label 1, 2 dekat sini. First oxygen berapa electron group?
3.
3. Kita ada 1, 2, 3. Double bond kita kira sebagai satu group. So untuk oksigen pertama 3 kumpulan. Okay, how about the second oxygen here? 4. We have 1, 2, 3, 4. So over here 4 electron groups. How about carbon?
3.
3. We have 1, 2, and 3. 3 electron groups. Are you clear about this one? Boleh ya? Okay.
Boleh.
Untuk kedua, nitrogen ada berapa electron group? Tapi kedua-dua nitrogen adalah sama lah.
2.
2 1, 2. Kedua-dua nitrogen sama, maka mereka sama. Ada 2 electron group saja. Okay. Any questions about electron groups over here?
No medium.
Okay. Kalau tak ada, kita proceed kepada lukisan. Okay. So why we want to, madam want you to recognize electron groups. So if you look at the table over here, electron groups, we have 5 electron groups only. From 2, 3, 4, 5, 6. In total, there are 5 electron groups only. Up until 6. Satu kita tak kira, kita start daripada 2 electron group. Okay. So let's look at the top one. Electron group arrangement. Once you know about electron groups, how many electron groups are they? Then we want to see how do we arrange this electron group inside the molecule. Okay, so based on Lewis structure, so nampak tak Lewis structure kalau salah, electron group arrangement dia akan ikut salah. So Lewis structure kena betul. So based on this Lewis structures, electron group arrangement depends on number of electron groups around your center atom. Okay, which will determine your basic shape of a molecule. Bukan molecular shape, ini adalah basic shape. So kita boleh cakap dekat sini. Electron group arrangement is the same as the basic shape. So since we have only 5 electron groups, we have 5 basic shape. Total ada 5 kumpulan. Okay, so A represent your central atom, X represent your surrounding atom, and E represent your lone pair. So kita hanya pakai simbol untuk represent dulu ya sebelum kita proceed kepada example. Okay, so when we have the electron group 2 electron groups, the general formula goes this way. AX2. 1 center atom A and then 2 surrounding atom X. So the electron group arrangement adalah linear. So kita lukis dia punya basic shape guna A dengan X. A center atom, lepas tu kita ada X dekat sebelah dia. So if you can see over here, this is a linear shape. And then between the shape over here, we have the bond angle. Ingat, bond angle adalah between. Yeah. Okay, bond angle is between two bonding pair. So madam tulis shortcut dekat sini. Bond angle is the angle between two bonding pair. So antara bonding pair yang AX pertama ini, okay, between this bonding and this bonding, we have a bond angle of 180 degree. Okay, and then when you have three electron groups, okay, the general formula is AX3. And the electron group arrangement is Trigonal Planar. Semua ini nama dia adalah fix. Nama dekat kolom ini adalah fix. Sebenarnya semua fix lah, tapi awak kena faham, kena tahu nama dia. Trigonal Planar. So kita susun A, X yang pertama, X yang kedua, X yang ketiga. Okay, so this one is according to Vesper Theory. So remember, Vesper Theory, we say that we arrange the electron pair as far as possible to minimize repulsion. Sebab tu kenapa awak nampak ketiga-tiga electron pair dia macam equally spaced. So kalau dekat awak tahu satu circle 360 degree, right? So you separate into three. So each of them over here 120. So the bond angle 120. That is for Trigonal Planar. Okay. Any question up until this one? Untuk gambar yang sebelah nanti baru madam tunjuk awak kita completekan table ni dulu. Can you follow until 3 electron groups?
Yeah.
Okay. So for 4 electron groups, general formula X4, the electron group arrangement we name as tetrahedral. So we arrange this way. A, X1, X2, X3, X4. Okay. Dia bukan dekat satu planar kalau tengok pada structure dekat sini. Ini linear, senang, 180. Ini trigonal planar. Okay, look at this one, tetrahedral. So the arrangement is not exactly on the same plane. Awak akan nampak dia macam bentuk 3D. Okay, and then between the bonding pair, the bond angle is 109.5. Kena hafal. 109.5 degree untuk tetrahedral. Okay, sampai 4 dulu madam tunjukkan molecular bond. So this one, can you see the molecules moving?
Yeah.
Yes, madam, just a bit.
Okay, so the purple color one is your center atom, the A. Okay, kalau madam dekat bawah sini, nanti awak boleh guna website ini jugalah untuk tengok. So madam tunjukkan electron geometry. Electron geometry adalah awak punya electron group arrangement yang kita tengok sekarang. Basic shape. Okay. So kalau madam sekarang nak satu double bond, satu single bond, dia pun sama juga sebab group yang sama kan. Okay. Ataupun sekarang madam nak satu single bond, satu triple bond. Still the same, 180. Okay. Right. So this one is linear. What if we have a trigonal planar? So we add one more. So you will see the bond angle is 120. Kenapa kita panggil dia trigonal? Sebab dia ada 3 kaki. Dan kenapa kita panggil dia planar? Sebab kalau madam letak macam ni, awak nampak satu plane saja. Okay, so this is trigonal planar. Okay. And if I have 4 electron groups, let's say sekarang madam tak nak ni, madam nak satu double bond. Boleh juga. So this is how it's actually looking. Sebab kalau dekat kelas madam ada model, sekarang tak ada, so kita main 3D structure sajalah. Okay, so this is your tetrahedral. Nampak dekat bawah sini electron geometry tetrahedral. So bond angle antara bonding pair adalah 109.5. So dia dalam bentuk 3D. Tapi bila awak lukis sama macam madam macam ni je. Is there any questions? Ada soalan ke?
Ada.
Nah, ya. Okey, kalau tak ada kita proceed kepada 5 electron groups. Okay. When you have 5 electron groups, the general formula AX5, named as Trigonal Pyramidal. Susah sikit kena belajar spelling dia. Dan dia punya arrangement, kita arrange macam ni. A, X pertama, X kedua. Lepas tu dekat tengah-tengah sini ada 3 lagi X. And then bond angle dia ada 2. Okay. So before I showing you the bond angle, first we look at the structure here. Trigonal Pyramidal. 3 bonding pair on the plan. And then 2 bonding pair, 1 up, 1 down. So if you're looking at the 3D structure, so let's say Metal add 1 more. Metal tak nak double bond lah, semua buat single bond dulu. Okay. And I want you to look at this Trigonal Pyramidal. So you can see, Metal sekarang pusing dekat plan. Kejap Metal pusing kejap Nampak tak 3 kaki ni dekat plan yang sama? Metal sekarang pusing dekat plan yang sama. Did you see the 3 bonding pairs on the same plan? Did you see it?
Yes.
Okay. And then one is on top. One bonding pair is on top. Another bonding pair is on the bottom. So metal moving dekat sini awak nampak ya. Okay. So the names actually come from here. Trigonal means this 3 bond. Bipyramidal is come from the name pyramid. Tapi bi maksudnya ada 2 pyramid. So satu pyramid dekat atas, satu pyramid dekat bawah. Okay, so it's called Trigonal Pyramidal. So bond angle dia ada 2. Kalau kita tengok macam ini, hold on ya, where is my planar? Okay, so kalau madam buatkan dia planar, so awak akan nampak 90 degree. Okay, between the plan and the pyramid, 90 degree. Okay, and then the other one, 120, come from your trigonal. Madam nak cari kat mana trigonal kita. Okay, nampak tak trigonal? Did you see the trigonal plan? Okay,
Yes.
so the bond angle is 120. So untuk structure yang keempat ini, okay, kita punya lukisan pelik sikit lah. So madam arrange macam mana kita lukis. So yang madam ajar awak lukis adalah macam ni. Atas satu, bawah satu, dekat kiri kanan ada 3. Okay, so in this case, if we want to label the bond angle, 90 degree. And over here, 120 degree. Kalau awak rasa, madam, boleh tak saya lukis macam ni? Saya nak satu dekat kiri, 2 dekat kanan. Boleh, tak ada masalah. Kalau, madam, saya boleh tak letak macam ni? Kiri kanan satu-satu, lepas tu atas satu, bawah 2. Pun boleh. Dia sama je. Macam madam pusing tadi kan? Macam satu orang lah. Kaki, tangan dia. Ataupun macam satu star. You can choose the one you prefer. Sebab untuk yang 5 electron group dia agak susah lah. But you have to remember there is 2 bond angle. And the last one we have over here is 6 electron group. AX6. The name is Octahedral. So lukisan dia atas bawah masih lagi satu-satu. Tapi sekarang dekat sini, kiri kanan ada 4. And there's only 1 bond angle. Okay, which is 90. 90 over here, 90 over here as well. So semua adalah 90 degree. Darjah. Okay, so if I add 1 more, then you can see, okay, this one is octahedral. Okay, the four bonding pair in the middle, 1 up and 1 down. So if I turn over here, you can see there is a square plan. It's a square planar over here. So nama satu lagi untuk octahedral kita boleh namakan sebagai square bipyramidal lah. Tapi nama common dia adalah octahedral. If you want, you can write over here lah. Another name, square bipyramidal. But we are using octahedral more often. Okay. So any questions for the basic shape over here? Ada soalan ke? Dapat salin semua?
Dapat salin dah.
Dah salin. Right. So Madam want to make sure everyone's understand. Electron group arrangement, we include all the electrons group. The bonding pair, single, double, triple bond. Include also the lone pair. Include also the lone pair lone electron. Okay. We proceed into molecular shape. So over here, Madam give you the template and then we shall fill in together. Okay, so molecular shape, or we call it as molecular geometry, it includes your bond angle when drawing your molecular shape. So if you recall back, Lewis structures, dia hanya susun saja, kiri kanan, atas bawah, asalkan awak letak elektron, letak bonding pair. Tapi kita tak susun dia ikut bond angle. But when you want to find the the molecular shape, we must arrange your structures following the angle. In a simple words, Lewis structure with bond angle. Okay, so there's the steps that you need to follow. First one, draw the Lewis structures based on the molecular formula given, and then identify the electron groups, including both bonding pair and lone pair. Lone electron, not very common. Lone pair and bonding pair around your central atom. Then you need to write down the general formula. How many surrounding atom, how many lone pair. So ingat tadi lone pair kita pakai simbol E. Surrounding atom kita pakai X. Tapi yang basic shape tadi semua kita anggap surrounding adalah X. Okay. Step yang keempat. Okay, determine the electron group arrangement, which is also your basic shape. Out of that 5, which one is it? Linear, trigonal planar, tetrahedral, Trigonal Pyramidal, or octahedral?
Trigonal Planar.
Tak kisah, dekat sini cuma satu outline. So kita kena tentukan basic shape dia lah apa. So that is step number 4. And then after that, we want to apply Vesper Theory. Dekat sini Vesper Theory adalah kita bandingkan. Either lone pair repulsion is greater than lone pair bonding pair, or just bonding pair repulsion. So depends, Lewis structure awak ada berapa bonding pair ataupun langsung tak ada, semua bonding pair saja. So we have to look at the Lewis structure. Number 6, then only we determine the molecular geometry. So dia bukan terus pergi kepada molecular shape. Dia mesti going through this few steps before you find out the shape of the molecule. Okay, so I want you to highlight also for this one. I'm using a different color. For molecular shape, we only consider bonding pair. Okay, Madam will show you how is it. And last one over here, draw the Lewis structure in the form of molecular geometry with the bond angles. Okay, so this is a very general guideline lah. You're starting from the formula, you draw the Lewis structure, then you identify. Ya, ini Madam extract daripada internet. Electron domain geometry adalah awak punya electron group arrangement. Okay, ada berapa bonding pair, ada berapa lone pair. And last kali baru kita tentukan dia punya shape or the geometry. So this one is like a summary for you. So let's just try this one. Two electron group is always the simplest. Okay, because in this category, two bonding pair with no lone pair. Nah, untuk dua electron group, you only have two bonding pair with no lone pair. And electron group arrangement is linear. Molecular geometry is also linear. So yang ini sama macam tadi. Bond angle 180. Then you label over here lah. Linear adalah sama sebab basic shape sama dengan molecular shape. Okay? Boleh ya?
Boleh, madam.
Okay, kita proceed kepada three electron groups. So just now we said three electron groups. You have the electron group arrangement or your basic shape of Trigonal Planar. Okay, but you have two combination. I can have three bonding pair with no lone pair. The general formula is AX3. Then the molecular geometry is still the same. So it's still like just now, AX3, arranged using 120 bond angle. So dekat sini kita label lah. Salah satu angle sajalah sebab semua angle adalah sama. Okay, but there is also the case where you have only two bonding pair with one lone pair. Sama juga total dia adalah 3 electron group. Ini total adalah 3. So dia bawa kategori yang sama, 3 electron group arrangement. Okay, you can see 3 electron group arrangement, Trigonal Planar. 3 electron groups arrangement also Trigonal Planar. But the general formula now change a bit to AX2E. Dua bonding pair, satu lone pair. So now the molecular shape change a little bit. Since we have only two surrounding atom, 2x, x2, so kita letak macam shape Trigonal Planar juga. Tapi dekat atas A kita ada satu lone pair. Okay, so now we back to just now our step number 6. Molecular geometry consider only bonding pair. So awak tengok sekarang dekat sini. Consider only bonding pair. Tutup dekat lone pair dekat atas. Awak akan nampak satu V shape dekat sini. Or a band shape. Because we know that this is lone pair. Okay, Meda guna warna lain untuk kita applykan Vesper Theory. So this is lone pair. This is bonding pair. Lone pair bonding pair repulsion. Okay, lone pair bonding pair repulsion is greater than bonding pair repulsion. So now we are applying your Vesper Theory. Okay, because we want to arrange the electron as far as possible. So in this case, kita tahu in general Trigonal Planar, bond angle is 120. But because of this lone pair bonding pair repulsion is greater, now the bond angle. Ingat bond angle kita hanya tengok pada bonding pair sahaja. Ini adalah 120 tapi dia kurang sikit. Sebab repulsion dekat sini dia lagi besar. The repulsion over here is greater than between the bonding pair. So now they squish in. So madam show you over here. Okay. So if you look at 3 electron group, madam show you the molecular geometry. Okay, so now you can see the bond angle. The lone pair is on top. You just drawing the lone pair without the macam satu muka hantu macam tu tapi tak payah letak satu dropper shape like that. Okay, so this bond angle is actually shorter than 120 because repulsion is greater. So dekat sini awak boleh nampak lah electron geometry Trigonal Planar sebab dia termasuk lone pair dengan bonding pair bila kita kira electron group. Tapi molecular geometry ataupun molecular shape kita hanya consider bonding pair sahaja. So penting awak boleh recognize bonding pair maksudnya apa. Okay. So we back to this structure. And please recognize the bonding pair here now is less than 120. Okay, due to this one. So any questions about the shape for 3 electron groups category?
Actually push the bond pair repulsions, am I right?
Yes, you're pushing it, squeezing it.
So squeezing it, making the angle increasing.
Hazin, I think your speaker having problem, yeah?
Madam.
Yes.
So in this situation, the long pair bond pair is squeezing the bond pair repulsion, making
Yes.
the angle decreasing.
Yes, good. Yeah, exactly.
So it wouldn't be 120, maybe it can be 90 or 100.
Yeah, you just write less than 120 only. You don't have to find the exact bond angle.
Oh, alright.
The exact bond angle only for certain species. For example, like H2O and H3, the common use. But for the rest of it, you just write less than using this symbol. Okay. Wow. Hold on. So we proceed to another category, which is your group 4, 4 electron groups. Okay, so 4 electron groups, we can have combination between 4 bonding pair with no lone pair, 3 bonding pair with 1 lone pair, or 2 bonding pair with 2 lone pair. All together give you 4 electron groups. So the electron group arrangement are all the same. Now this is the electron group arrangement, tetrahedral. So the general formula AX4, which will give you back the basic shape. Sebab semua adalah bonding pair. So kita punya molecular shape masih sama macam EGA, electron group arrangement, 109.5. Okay, and then the bond angle you can label inside your molecular shape, 109.5. But if you have the combination between 3 bonding pair and 1 lone pair, you will give you the shape Trigonal Pyramidal. Okay, so A ada 3x kat bawah dengan 1 lone pair. And the bond angle now, because of the Vesper Theory, okay, lone pair, bonding pair repulsion is greater than bonding pair repulsion. So ini adalah wabinya lone pair, bonding pair repulsion. Ini adalah wabinya bonding pair repulsion. So kalau kita nak label dia punya bond angle, it should be less than 109.5. So kita ada label kat sini 109.5 degree. Okay, so what do we say it is trigonal pyramidal if you look back at the shape over here? Kalau tak ada lone pair, dia punya shape adalah tetrahedral. So looking at the left bottom here, tetrahedral. But what if I replace one of the surrounding atom with lone pair? So now you can see the shape is look like a pyramid, a small pyramid, but it has 3 legs, so trigonal pyramidal. Dia bukan planar untuk tadi kita ada planar. Ini bukan atas planar. Maksudnya center atom is not on the same plane as the surrounding atom. So ini adalah pyramid. Okay, so the bond angle should be less than 109.5. Okay, and the last one in category 4 here, we have 2 bonding pair with 2 lone pair. So sama jugalah kita buat A and then X ada 2. So now I have 2 lone pair. Okay, it's actually based on your electron group arrangement and then we remove. Okay, untuk EGA kita memang ada 4 surrounding. Tapi sekarang ni kita replacekan dua benda ni dengan kita punya lone pair. So it look like this. I have two lone pair on the center, A atom. So when you have two lone pair, then your Vesper theory have one more category. Your Vesper theory now say that lone pair repulsion antara dua lone pair ini greater than lone pair bonding pair repulsion between two of this is greater than bonding pair repulsion.
Madam,
Yes.
when we want to replace the lone pair, dia mesti sebelah-sebelah ke macam mana?
Dia mesti ikut Vesper sejauh yang mungkin. Sebab lone pair sebenarnya dia punya repulsion yang adalah paling kuat. Okay, so we have to replace it the furthest as you can. But if you look at this one, if I replace one of the lone pair over here, tak kisah saya replace mana, dia memang duduk sebelah. Tapi ini untuk tetrahedral electron group arrangement saja. Sebab tak kisahlah saya kalau nak tukar ini, kaki yang madam tengah goyang ini, okay, dia masih sama sebelah-sebelah. So this is for 4 electron groups with 2 lone pair and 2 bonding pair. Cuma madam tak dapat nak tunjuk macam mana dia repel. Okay, so dalam awak punya lukisan 2D, dia nampak macam ni. Nampak satu bend shape ataupun V shape. So molecular shape will only consider bonding pair. So tutup atas yang ada lone pair, awak akan nampak satu V shape lah untuk bonding pair dia. Boleh ke nampak? Madam risau ni.
Madam, sejauh mungkin macam mana madam? Saya tak faham part tu.
Yang mana satu?
Tadi madam cakap dia kalau boleh sejauh mungkin. Maksudnya?
Maksudnya okay, madam lukis right, Ija, you look at this one. So now we know the basic shape is like this. So if let's say madam replace this one, it's still sitting beside, isn't it? Okay.
Okay, faham.
If let's say madam want to replace this one, it's actually when I turn around, it's still the same. It's still looking like this. Or if madam replace this one, it's still the same like this. So dia masih sebelah-sebelah sebab dia adalah tetrahedral. So tak kisah awak replace mana satu X, dia masih sebelah-sebelah dia.
Okay, madam faham.
Kalau madam tambah satu lagi, awak akan nampak. Kenapa kita letak dekat sini? Sebab bond angle dia adalah yang paling jauh, 120. Kalau madam tambah satu lagi, awak akan nampak. Okay, lone pair sekarang paling jauh. Sebab dia on the top and on the bottom. Do you get what I mean?
Yes, madam, yes.
Okay, so bila kita nak letak lone pair, refer balik Vesper as far as possible. That is the keyword. Okay, so we back to this one, yeah? Alright, so the bond angle now between the bonding pair, also we have less than 109.5, but this time much smaller than the previous one. So dia masih kurang daripada 109.5, so kita just letak range sahaja. Okay? Have you done jotting down?
Yes.
Okay, so tak ada dah. Ada kumpulan 5. Okay, 5 electron groups. So 5 electron groups, there's 4 combination. So ingat 2 electron group, 1 combination. 3 electron groups, 2 combination. 4 electron groups, 3 combination. So now we come to 5 electron group, we have 4 combination. 4 combination ialah 5 bonding pair, tak ada lone pair. 4 bonding pair, 1 lone pair, 3 bonding pair, 2 lone pair, and then 2 bonding pair, 3 lone pair. Ini yang paling susah. 5 electron group adalah paling susah. Okay, so electron group arrangement is the same, Trigonal Pyramidal, but the general formula, it depends on your combination lah. Okay, so we start with the easiest one, 5 bonding pair. So over here we have a X5. Okay, ada 2 dekat tepi, 1 dekat tepi sini. So bond angle 120 and 90 degree. So you'd have to make sure you understand lah. This one is 90 degree, and then between here is 120. Okay. So next one we come into seesaw. Macam mana kita dapat seesaw shape? This is when you have 4 bonding pair with 1 lone pair. Macam ni madam tak nampak seesaw pun. Tak apa, madam buat melintang. Ini adalah kaki seesaw. Ini tempat yang awak duduk, adik awak duduk. Ni nampak tak satu seesaw? So this is your seesaw shape. Okay. Lepas tu lone pair dekat atas. Ingat shape hanya ambil bonding pair sahaja. Okay. So the bond angle now we will have less than 120, less than 90. So madam tunjukkan seesaw shape dia macam mana. Okay. Here we go. Original kita ada Trigonal Pyramidal kan, 5 electron group. So ada 2 pyramid, 1 trigonal plane. So sekarang kita gantikan satu surrounding atom dengan lone pair. Okay, and now you can see the seesaw. Macam satu orang kan, kepala dia kita tukar dengan lone pair. So now you can see this is a seesaw shape. Tempat itu saja yang kita gantilah. Sebab dia punya jarak paling jauh. Dekat sini ada 120. So if I put it over here, you can see the repulsions. That the lone pair have a greater space for it to repel. Dia ada ruangan yang besar untuk dia buat repulsion. So kita kena letak dia sejauh yang mungkin. Okay, so seesaw shape either this one or this one. Which one you prefer? You draw it. Okay. The third combination we have AX3E2. 3 surrounding atom, 3 bonding pair, and 2 lone pair. Okay. So kalau ada 2 lone pair, kita akan gantikan. Okay, madam tukar balik dekat sini untuk senang awak nampak. Lone pair, lone pair. Okay, so now you will see a T shape. T shape, over here we have 90 degree as the bond angle. Okay, T shape we have a 90 degree as bond angle. This is your bond angle. And if you want to look how they arrange, now I put another lone pair over here. So dekat sini adalah awak punya T shape. Kenapa kita letak lone pair dekat sini? Sebab dekat sini bond angle dia paling besar, 120. So we put on the planar there. Okay. So dekat sini adalah satu T shape. So dalam awak punya diagram yang madam lukis adalah macam ni. So 2 lone pair madam letak dekat sebelah sana. So baru awak akan nampak T shape. So, awak kena ingat 3 bonding pair, 2 lone pair, dia akan memberikan shape, T shape. So you remember that way. Now 5 electron group, 3 bonding pair, 2 lone pair, give you T shape. So kalau dekat sini pun ada jugalah kita punya Vesper Theory. Okay, so in your AX4E3 Vesper Theory, dia adalah lone pair bonding pair greater than bonding pair sebab dia satu lone pair sahaja. Dalam combination AX3E2, kita sebab ada 2 lone pair, so maksudnya dekat sini ada lone pair repulsion, lone pair bonding pair repulsion, bonding pair repulsion. And last one, kita ada 3 lone pair. So macam mana nak nampak 3 lone pair? So sekarang sama jugalah. Replacekan satu surrounding atom dengan kita punya lone pair. So you will see there is a linear shape. And we locate the lone pair as fast as possible. Dia tak letak dekat sebelah kiri kanan sebab dia punya bond angle hanya 90. Instead we put on the bond angle with 120. Okay, so combination 3, 2. 2, 3, 2 bonding pair, 3 lone pair, give you the shape of linear. Okay. So untuk 5 electron groups adalah yang paling complicated lah. Harap awak boleh revise balik. So linear shape, you have 3 lone pair around here. Dan semua ini adalah untuk expanded octet. So if you can see central atom, they have 10 electrons here. Okay, so untuk 5 electron group is actually for expanded octet. For the element that is beyond period 3. Ayo. Kemana saya nak buka? Okay. Okay, expanded octet for elements beyond period 3. Period 4, period 3, period 4, period 5, period 6. Because the central atom now having more than 8 electrons. So now the bond angle 180. Senang ke susah? Hi guys.
Boleh lah.
Boleh lah.
Dah belajar tak ada susah mana.
Okay. Right. So for 6 electron groups and the examples over here, Madam will discuss on Thursday. Thursday there will be classes, yeah, from 11 until 1. So we will discussing. We will continue 4.2 and maybe enter a little bit of 4.3. Okay. So this is the video for you to suggest for you to as a reference or to refer. So you can access from the OneNote here. Okay, so Madam nak buat sikit quiz Quizzy. A very short one, 7 questions. Are you ready? Simple je. Boleh ya?
Boleh je, madam.
Make sure every
Access the quizzing.
Where's the link?
no link, enter the code.
Alright.
Zero 53314.
052314.
Madam, cannot hear your voice.
Madam mute ke?
Oh, bila dia main quizzy dia akan tutup terus Dengar tak?
Yelah, dah dengar.
Okay.
Yes, madam.
Ya, 72, kita tunggu sekejap lagi Madam akan ambil masa sikit tau. Boleh kan?
Boleh.
Boleh, madam.
Madam mulalah. Kesian awak. Okay, we start 8, 7, 6, 5, 4, 3, 2, 1. Form a tetrasulfur.
0.
Yes. So we have 0. Why got positive 2? Madam nak nangis. 6 tolak 2 tolak 4 bagi 0. Ingat satu dot kira 1, satu line kira 1. Okay, next questions. Nama penuh untuk Vesper Theory, VSEPR. Cipu got it correct. Well done. Okay, most of you got it correct. Yeah, Vesper Theory, Valence shell, electron pair repulsion. And the next questions we have. What is it used for? Hopefully everyone can answer this one correctly, yeah? Time's up. Okay, well done. 65 of you. Molecular shape. Oh, bila masa madam cakap pasal bone strength. Vesper Theory is for today's lesson. Bone strength is the other day. So molecular shape is what we use the Vesper Theory for. And next questions. We got linear, trigonal planar, trigonal pyramidal, tetrahedral, octahedral. Altogether, how many basic molecular geometry? Same as electron group arrangement. Okay, well done. We have changing in the leaderboard here. 52 of you got it correct. Tok tok tok. Basic shape ada 5 6 maksudnya kita sub daripada 2 sampai 6. 2, 3, 4, 5, 6. 5 basic shape sahaja. Next questions. Linear molecule bond angle sangat senang. Okay, and 71 of you got it correct. Well done, 120 is the correct answer. And we have got it next. NH3 with 3 bonding pair, 1 lone pair. Okay, similar with the general formula AX3E. So what will be its shape? Any extra questions, Whoa, Safika, raise up the places. We got quite a few different one, yeah. Shape we only consider bonding pair. Okay, so hanya ambil kira NH sahaja. Tanpa tengok pada lone pair, so awak hanya fokus kat bawah saja. Dia adalah Trigonal Pyramidal. Boleh tengok pada jadual tadi yang 4 electron group where you have the combination straight bonding pair with one lone pair. Tapi untuk real structure madam belum ajar lagi. Cuma ini boleh refer kepada yang general yang kita pakai AX. AX3E. Boleh rujuk ya. And the last one also an extra. CCl4 ada 4 Cl ada satu Cl dekat belakang. So ini shape apa? Kalau semua surrounding atom ada tanpa lone pair. Yang ini molecular shape sama dengan electron group arrangement. Basic shape dia. Congratulations for those who are on the leaderboard here. Right, so the correct answer, well done. Most of you got it correct. So we have the original basic shape because all the atoms are there and we don't have any lone pair. Okay, so the shape is tetrahedral. Okay, so in our next lesson, Madam bagi kerja sikit ya. Kat mana kerja Madam? Okay, kalau awak dekat Google Drive kan ataupun dekat MyLink Madam, awak akan nampak satu template satu macam ni. Okay, so Madam nanti akan hantar satu video, Madam tunjuk satu contoh dan Madam nak awak buat kumpulan 2. This is the homework to be submitted in GC. I want you to complete this table for group 2, group 3, and group 4. 3 table ni saja. Tapi nanti Madam akan hantar satu video untuk tunjukkan cara macam mana awak nak completekan jadual ni. Is that okay, everyone?
Okay, Madam.
Okay, madam.
Okay, Madam.
So dalam GC hanya 3 ni saja 2, 3 dengan 4. 5, 6, if you want to complete it, feel free to. But sebab 6 Madam belum bincang lagi, so we will hold on for this one first. You want to try, feel free ya. Sebab Lewis structure sebenarnya dia sama. Cuma awak isikan electron group arrangement, so on. Okay, so today until here only. So thank you everyone. Did I miss out something? Tadi kan? Ada soalan nak tanya?
No, madam. I think that's all.